Hello and welcome to Koortcast, the podcast that aims to give you a glimpse into the world of Koort coding schools. Join us for interviews with school alumni, current students, industry visionaries and other fascinating guests. I'm your host, Priit Koff. Enjoy! In this Koortcast episode, we are joined by Koort CEO Lauri Haav to discuss artificial intelligence and programming with Joosep, Simm and Kaido Koort, who have recently published an ebook on how artificial intelligence can help budding software developers. Tallinn Education Board Director Kaarel Rundu and Maive Merkulova from Tallinn German Gymnasium reflect on how to get high school students excited about software development skills. And finally, we talk to educational psychologist Grete Arro about learning to learn and how our brains can be rewired for even seemingly impossible tasks. And hello and welcome back to the studio. And joining me here today for a very special edition in this podcast are, first of all, Joosep, Simm and Kaido Koort. And also joining me as a co-host on this very rare occasion is Lauri Haav, the CEO of Koort.
That's a first.
That's a first for us. But the reason why we have you guys here is because you seem to be genuine experts when it comes to the world of artificial intelligence. And you have even published a book about AI coding for beginners. And this is primarily the reason why we wanted to have this conversation with you, to talk about whether artificial intelligence will be replacing software engineers in the future and how can artificial intelligence be of assistance to coders. But before we get to that, perhaps you could introduce yourself with a few words. So Joosep will go first.
Maybe I start from the beginning. So my mother and father learned computer science already in Soviet times. They were my mother is programmer, but never taught me this thing. And but I still wanted to learn it and went to Taltech. It was called differently back then, but yeah, basically I learned software engineering there, and yeah, Then I did some kind of ad hoc work, jobs, but ended up in Nortal as a Java programmer, and from there did a lot of different things, different companies, been programming Java, Golang, iOS app, making blockchains in Golang, I said, web pages, all sorts of things.
And if you were to summarize what you do today, how would you describe that in one word? Or maybe a few more?
So today I'm still software engineer. I write Python and work in Estonian startup called Grete Arro.
Mm-hmm. Okay. And what about you, Kaido?
Yeah, hi. I've been in IT for 22 years. I also went to Taltech, studied computer engineering. Then started to work while I was in university across the street in Starman. I started out as help desk, as many in IT do, and then moved on to IT analysis and leadership roles. Spent about 7 years in IT operations side, and then also started or got interested in product management, and also went to work at web media or Nortal. And I've also worked in SKID Solutions as head of development during Smart ID inception, and in Make Commerce or Maksekeskus in Estonian as a CTO, and last role was in LHV Insurance as a CTO as well. So I have some 6 different product development experience. Some of them together with Joosep, we've jointly created a board game about colonizing the moon. That's called Lunar Base. We've created an app called Surfcast that's meant for surfers to predict when they can surf from their busy schedules. And it scans the next 24 hours forecast, and if there is a good enough wind in your chosen spot, then it sends you a message that you can surf tomorrow.
And now we created the book together.
Okay, but before we get to the book, then you did write the book together, but to get to your personal background, then you've been friends for a very long time, and I think the term that we're looking for here is actually gaming buddies. That you started off as playing computer games, and that's how you made your connection. That's what I read in the blurb of your book, at least.
Yeah, like back in the days, I was organizing LAN parties, like in school. We had internet back then, but it was quite slow. Or like anyway, a lot of people came together with their own PCs. We connected with cable to same network and played Counter-Strike and StarCraft or whatever, Command & Conquer, things like this. And then Kaido came to one of those parties, and then we became friends.
Okay, and now you're writing books together, but before we get to the book part, then perhaps let's talk a bit more about your journey to the world of artificial intelligence. When was the first time that you remember you heard about this term, and how did you get more into it? What were the leading steps?
Well, my memories from the Dune book series, where I learned about artificial intelligence and like the pre-sequels for the actual like the most famous like 3 books that are written. There were thinking machines who took over the world, and then basically humans destroyed all of them. And in the original like 3 books, there is no artificial intelligence anymore because it was banned, because they took over the world. But I've been reading a lot of science fiction, and usually there the AI is like the companion of humans. So like soldiers have their own, like soldier AI, scientists have their own. Usually it's implanted into the brain or somehow. And
okay. And Kaido, what about you?
Pretty much the same. I grew up with science fiction, reading books, watching movies, and I have this recollection of one specific moment, like a year or 2 ago, when we were hiking together, and then I was thinking, damn it, that this AI revolution is happening, and it's like everything that I've been dreaming of or reading about or watching and fantasizing about, and like I can't miss this. This is my time, because I'm very well positioned to leverage this, and I have a good like feeling that I have some understanding how can this unroll, or what will happen, or what will be the most probable outcomes. So that's why I've decided to basically quit the day job and start working on this, testing different tools, starting an AI development agency, like writing a book, or like testing different kind of solutions.
Okay, well, this is a possibly a very dramatic introduction to the topic, but if you know what's going to happen, and you said that you've read many science fiction books where artificial intelligence is either a companion of humans that helps them, or it's something that humans want to get rid of because it's trying to overtake their lives. So which scenario is more likely, in your opinion? What is going to happen? Is it going to help us, or is it going to destroy us before we destroy it?
I think the companion like path is most probable, because I think we see when it starts to get out of hand, and I mean, humans are quite ingenious and quite capable of destroying things, so I think we can do it. You know, accidents might happen and people might die, but not like wipe out the whole humanity.
Okay, so we're not looking at a Terminator Judgment Day kind of doomsday scenario, in your opinion, at least.
Yeah, I think so, yeah.
Oh, that's reassuring. So at least there's point in us actually continuing this discussion. So a bit more optimistic, Lauri, would you have... You seem to represent the more optimistic side of things when it comes to artificial intelligence. Would you like to chip in at this point?
Yeah, sure. So I just realized that we have So me and Joosep, we used to work together in one startup a couple of years ago, but I just, from your intro, I realized that we have something else in common as well. So my mother is also a programmer and a computer scientist. But since my father is not, then I only got half the bug. So I'm mostly been in IT, in business side of IT, not on the programming side until now. But so super cool to have you guys here with us today. What was the question again?
That was the question was that you seem to have a very optimistic view about the world of artificial intelligence.
I don't know if it's very optimistic, but I'm kind of like in layman's terms, I'm kind of thinking of it like, like Jeremy Clarkson has this Clarkson's Farm series where he starts to run a farm and he doesn't know anything about farming. But then basically, you can use like a big tractor, like a combine harvester. It can do many things, but you need to know how to run it. And you need to know how to use it and for what. And you can put a monkey behind a combine harvester. They will not get you a good farming outcome. And the same story, I think, a little bit relates to AI as well, that if you don't know what you're doing, it's not going to help you that much. You still need to know what you're doing. So, for example, if I would use AI to maybe write a poem in Chinese, I can do that, but I wouldn't know if the poem is a love poem or if it tells you to sort off, basically, right? I wouldn't know that. And therefore, it's not really helping me unless I also understand some concepts or some principles of it, and then it can be super powerful tool.
What I've discovered when playing around with this different kind of AI tools is that sometimes that it also happens that they don't save you time, but that's the learning curve. That's always part of being like when you're being an early adopter. You sometimes discover that, okay, I've spent like 5 hours on this damn thing, and if I would have done it manually, the old-fashioned way, it would be already done like many hours ago. But that's part of the learning, and that's the price you have to pay. But most of the cases, most of the times, it still saves time to achieve the result. You just need to know what kind of tool to use for which occasion.
And maybe we can jump ahead and to the next question, probably in like viewer's mind, is like, will the AI take over the developers' jobs? Because I mean, that's I've been asked this so many times. But I don't see that it will happen, because I think in combination, human plus AI will be still better than just pure either. And I think that this is where the like future will go, that you're always working together with this AI, and AI is basically a tool. Maybe it gains more autonomy. We'll see where the limit is. But still it's the human who like has the values and makes the decisions, and basically it empowers the developer.
But what kind of skills would a person need in order to harness the true power of artificial intelligence? How to make it work, how to operate it properly?
Well, English is good.
That's a start.
But I mean, you have to use the tools and learn those tools as well. And then, of course, this field that you are working in, you have to learn that one.
So there are separate tools for separate fields is one thing that I've learned.
Yeah. And I think Lauri's example is very good. Like, if you don't know Chinese, you cannot write Chinese poems. So if you don't know the programming language or the like technology, you cannot actually build anything with those tools. Well, you can do something, but you don't know if it's good or bad or
right. So in order to know which question to ask from artificial intelligence, you first of all need to understand something about coding to begin with. It's not just something that any layman can do.
I don't necessarily agree. I'd say that in long term, the most important thing in my head is at least the mindset or the trajectory that you're on. If you're ready to learn, then AI is very good teacher. If you know how to ask the right questions, it can help you learn coding as well. So you can start with basically zero knowledge. Just you need motivation to start interacting with the tool, and like that's the most important thing. That when we're discussing that, like we don't need any more junior developers, AI will do everything. I don't I don't think that's the case if you are open to growth and you are open to learning. So AI can be a very good teacher.
How can AI tools help junior developers? I mean, when they're really at the very beginning of their learning curve and then they're trying to understand what this coding business is all about and how AI works and things like that. What specific tools are there that can be of assistance to a junior developer?
I think the most common tools are for juniors very good. And the main thing is to use those tools to explain what is happening and maybe get the first like working version as well from the tool, because they can quite easily create you proof of concepts or like small examples, but then let it also explain why it happens and to understand it, because it saves a lot of time when you compare with like understanding it the old way, let's say, because in the old ways you have to dig up the documentation or reference manual from somewhere or Google a lot, read through a lot of blog posts, but this LLMs really shorten this path and they explain those concepts quite easily, and if you don't understand you can ask more.
Okay, well, I'd like to provoke Lauri now a little bit. We've just learned that artificial intelligence most likely will not make junior developers redundant, but will it make Koort redundant?
That's a really good question. Actually, I was about to ask Joosep from the perspective, like, if you go back to the time where you didn't know how to code and you would start learning now, like what parts of your learning so far would be completely useless and what would still be valuable from the things that you've learned before AI? I mean, like if you would start from afresh, what would you scrape out completely and they don't bother learning that? And what parts are still valuable on your journey as a established software developer?
Actually, I wouldn't scrap out any knowledge, because it's still good that I know things and I can spot mistakes from AI output quite easily because of that. It's rather that the tool itself is it's like a private tutor in your pocket or in your PC that's now available. And it's still up to the person to learn the field and like all the details of how the machine works to be a good engineer.
Yeah. So maybe coming back to your question then. So first part is like trying to explain why it makes sense to learn anything and not do all the tasks that we provide for the students with AI is like almost like, would you send a robot to the gym instead of yourself? What would be the value of it?
It would take time.
Somebody would go to the gym and lift weights on your behalf, or would go and run in a forest or go skiing, and you sitting on the couch eating chips and drinking Coke, then probably wouldn't be too helpful, right? So that's the kind of the part that at least we try to still explain to people that if you want to have some skills and knowledge, you need to go through certain things to learn those skills. How you later deploy them is a little bit of a different story. But you still need to learn and understand what it is that you're doing or what the machine that you're guiding is doing, because otherwise you wouldn't know how to evaluate the output, how to fix any errors, or how to integrate the output into existing code base, which is also, I think, something that, I don't know, you have glimpsed into the future, and I don't mean Dune, I mean the tools that are currently available. How far away are we from a situation where you can also use AI tools to really combine very old sort of legacy code bases with something new that you're developing and something in the middle?
I don't know. I think that when you deal with legacy code base, it's AI also is quite useful as in explaining what a specific file does, or like a module in a software. So that's also saves time and allows you to understand quicker, what's this legacy code base about, and like what could be optimized and how to start to like improve it or integrate it with the newer systems, or how to start building on top of it.
That's now really bad news for all the COBOL programmers out there who thought they have job security for life.
We haven't tried it ourselves, but I can imagine that AI should be quite good in refactoring parts of code as well, as long as you can evaluate the output and if it's for instance, I'm playing around with this tool lovable.dev. And the tool itself already suggests that, okay, this file is getting too big. Should I refactor it? Okay. It's already here, this kind of functionality.
So the COBOL programmers are still back because they need to evaluate the output. At least some of them.
Yeah.
Well, now industry jokes have been done now, so we can now go back to talking about stuff that people understand. Thank you very much for that. But let's just briefly talk about this book that you have just written, AI Coding for Beginners. And what I really admire about this is that it actually says it's the winter 2025 edition. So can we expect the spring 2025 edition to come up soon? How quickly is this world changing?
So very good question. So the industry is changing very fast. So that's why you put the winter edition there. Because by summer it's definitely outdated already. At least the tool comparison part. But this book has some those evergreen ideas as well. But we already talk a bit about them, like how to use those AI tools for learning and stuff like that. So these are still valid, I think, also in summer, in next year, and so on. But yeah, when do we do next edition? We'll see. I think summer is a good candidate, but not making any promises right now.
I have a question. Will Joosep and Kaido do the next edition, or have you written an AI that will do the next edition?
We like to play around with the tools, and that's why we just the book is a like a side project because we will test and try out the tools anyway. So we figured that we might as well write a book. So that's we will definitely be the ones testing the tools and trying them out and seeing the goods and the bad and the ugly, let's say. But yeah, I think that next Wednesday we are already testing some like full stack development tools and trying out new toys.
Okay, but to summarize this, in conclusion, we can still all agree that there's still going to be needs for junior developers. There's going to be some AI tools that will be of assistance to senior developers, and there's definitely a future for choreography as well in the future. Are we all in agreement on this matter?
I don't know, are we?
I'd like to believe so, but those junior development positions, I don't know exactly what's going to happen. Maybe it will change a bit from the old times. Well, I work in a startup where we don't have any junior developers, but I mean that was the case before as well. But I think it's a question to some bigger company who had junior developers, and the question is are they still valuable? Because I would like to think that they are, but I mean they also have to start using those tools. So
well, it's likely that they will just remain as junior developers for a very short time and immediately graduate to become senior developers with the help of AI tools.
Mm-hmm. Yeah, I have some recent experience in working with junior developers and helping them to grow. And my take is that the main value of a junior developer is the energy and the initiative and the ability to, let's say, grab the bull by the horns and just start doing it. Many of the senior people have this. They have more habits. They need maybe more context before they start. But many of the young people, they're just you give them a task and they start to go. And when they get stuck, if they know how to ask questions and directions, then they are able to move much more quicker than senior people actually. So that's why I definitely would like to work with the junior developers as well, and like to employ them in projects as well.
Thank you for that. This is very reassuring, and our viewers now can be confident that there's a future in coding, and it's definitely worthwhile to apply now to Koort coding schools. And joining us today were Kaido, Koort and Joosep Simm, and their new book, AI Coding for Beginners 2025 Winter Edition, is out now on Amazon. So thank you very much for joining us, and look forward to the 2025 summer edition of your book, and good luck in the world of AI as well. Thank you.
Thanks.
Hello and welcome to Kaarel and Maive. Welcome to the studio. How are you guys?
Hello.
Why don't you actually introduce yourselves a little bit with a few words, who you are and what you do and why you're here in a way.
I am Maive. I'm the head of Tallinn German Gymnasium. And I have been there for some time, not being the head for a very long time, but I have been a teacher for a long time there.
Okay. And Kaarel?
Yes, my name is Kaarel. I'm the head of Tallinn Education Department, and previously have been also a principal at a school.
Okay, and which school was that?
In Maive school,
Aha.
in Tallinn German Gymnasium.
So there is a connection here. That's interesting. And
Yes.
this is something that we didn't actually plan on at all. But I think the reason why we invited you here was so that you could shed light on a new project that actually involves Koort coding schools and the Tallinn Educational Department, that you have something that you have been cooking up together. Could you explain to us a few things about that, please?
Yes, we were together with Lauri on a trip in Azerbaijan, where he was introducing the concept of kood, and we were chatting about different possibilities to work together, because kood as a concept is very interesting. No teachers, focusing on teamwork, on self-directed learner, on personal learning paths. And Lauri said they are working on different courses for gymnasium students. And we in Tallinn and especially in the education department are very interested in trying out new things. I think this is also a big part of the Estonian digital success story that started with the Tigrihüppe project, and 2 weeks ago our president Alar Karis also stated that they are working on new project for the fall, how to use AI to open it up for teachers and students also in the schools. So I think this was the push. And I was very happy that we met this fall, and they said that until the end of this school year, they have 3 courses regarding programming, data analysis, and one more that I can't remember right now, where the coding, programming languages, and how to work with them come together. And we saw it as a wonderful opportunity for our schools. We said we are prepared to do a pilot with 10 schools in Tallinn and support them so that they can extend their courses that they offer to students. We see that a lot of schools are working on programming, offering this. Sometimes there aren't enough teachers, and we like to have like a systematic approach. And what excited me also was that we got to do, I think, 2 or 3 exercises, and those, I don't have a background in programming and it was very attractive for me to work with the exercises, how they are built, how I can learn from that. And we thought like this is a good thing for our schools. So that was the starting point for our cooperation.
Okay, so 10 schools will be offering specific programming classes that have been put together by Koort's coding schools.
Yes, and we hope that even though just 10 are supported by the city of Tallinn, that more and more schools will take this chance up to individually work together with Koort.
Okay, and Maive, let me ask you then, what is it that kids are into these days in high school? So is this programming something that can attract the attention of the modern day high schooler?
Definitely it is programming, but I think that as technology is so advanced and all the students can use internet and find whatever they are interested in from there, then I think this variety of interest is really wide.
Okay, but do you think that this is the kind of a skill set that will actually pave the foundation for the future success of your students? Is this something that you consider to be a critical skill for future work or something like that?
It definitely is. I'm quite sure of that, because if we talk about the future skills of today's students, then definitely one of those is connected to technology and digital technology, but also some soft skills.
Okay, but allow me to briefly talk about a myth also that has been going around, just to get to the understanding of how this extracurricular activity is actually set up in schools at the moment. That for many years now we've been hearing about kindergarten kids already learning how to program and how to do coding and things like that. But I understand this actually happens in some schools and in some regions, but not everywhere. So how would you actually describe the process and the development so far? That if we talk about today in the year of 2025, how do you actually see that this process has worked out? This getting kids interested in programming and coding and things like that.
I think one important thing is Estonia is very famous for its digital solutions and working together also with edX, Estonian edX, for example. I think what always, if we have delegations coming from a board, that we try to explain is that working with different digital approaches, solutions, partners, you have to be wise to use them on the right spots. When we are talking about school, it doesn't mean that all the lessons are, all the topics are thought using different digital solutions. Programming, you can do programming also with just some different colored cubes or whatever. You don't need it to be digitalized. So, and I think working with kindergarten kids is also the same. What we have in our kindergartens is a state curriculum. So we have, and also we have in schools, we have these 8 different competencies that have to be provided all over different subjects. And the last one added 2011 was the digital competencies. So if we are talking about sports or music or mathematics or learning different languages, we have already the approach there that the children have to work also with programs, platforms that help to learn. So the next step is programming, coding, robotics. I think in kindergartens we can talk that robotics is the basis of taking the first steps. And I know even the schools are working together with kindergarten kids to teach them what they have learned in school. I think your school also has a project with a kindergarten next to you, where I think sixth grade students went and showed smaller children what apps they use for robotics, what apps they use for mathematics, and everything starts from there. So if you're saying it's a myth, then I would say it starts in the kindergarten, but in smaller pieces. And you're right, not all the kindergarten kids are learning to program, but they are taking their first steps in this right direction to build on that.
Okay, so if we have this as a pilot project in a way, teaching programming and coding in high school, then do you think in the long term you could actually take this even a notch younger, by a notch younger, so that you could actually have this already in primary school, or perhaps even from first grade onwards? I mean, you could actually introduce this as not as an extracurricular option, but really as parts of the main curriculum. Would that be something that is worth discussing in the future for you as well?
Yeah, when we asked the schools, we had a questionnaire like, what are you doing right now? What do you want to do in the future? How do you see this working out for your curriculum? And we were really positively surprised, because we have different concepts. Almost in all the schools, we offer hobby lessons, the after-school activities that are where the options are already working on STEAM, on STEM, robotics, natural sciences, also different informatics or programming courses. We also have this wonderful program for girls, Unicorn Squad. It grows and grows. So, and also we have schools that have this modules where you have in the 10th, 11th and 12th grade a systematic approach, and we have others that offer like pieces from different parts that you can take up, languages and switch it with 3D printing, for example, where you can explore a wider branch. But I think talking about Koort, this 3-course selection, the attractive thing for the schools is that it's not limited how many of your students can go there. They can choose if they work on it during vacation, in the morning, in the evening, after the lessons, and they can use their own tempo. And if they are so eager to learn, they can do all the 3 courses in 1 year. And I think it's also possible to extend it to the 9th grade if there are really students that are excited to take these courses up. And I think it's a really wonderful tool to support this self-directed learner competencies.
Okay. But Maive, as a headmaster, do you think you will actually get a lot of excitement from your students in your school to enroll in something like this if the chance was presented to them?
I think that there won't be many students who would like to choose that as an elective course, but I think those who will choose it, those are really interested in it, and probably they're doing the whole 3 courses during, maybe 1 year, because they have this possibility. but I think there won't be many students like that.
But what can we do to promote then? To promote this opportunity to them and to get more students excited about this? What can we do as Koort? What we can do as headmasters, as education board? What are the key incentives to actually get students excited about this?
So, of course, the first thing is when just information spreads that there is possibility like that.
Mm-hmm.
Definitely that. Of course, everything else what's done in different subjects and digitally and so on. But I think we talk about students, but for me, the most important thing is those grown-ups who lead those ideas. And as it was said before, that not all the schools put extra effort into teaching digital skills, but I think the most important part is actually teachers, that we need teachers who are interested in that and who are motivated to teach students to do that. And as Kaarel said, that yes, this digital competence is one of the main competencies in curricula, and it is added to each and every lesson or every subject curricula, but at the same time, still it depends on this level of skills of teachers, how much do they use. So I think schools or curricula should put, or maybe me as a school leader, need to put extra effort into teachers.
But
that's the key.
If I can add something, I think Maive said it very well. The information has to spread, but I think also what's important is that the experience that they have learning and doing the courses has also to spread. So having tapped in, I had a very positive experience, and I would be very interested in what's coming next. And I hope that after the first year, the students that are taking this course will share their experience, and then we get more and more students to take it. And what Maive also said, that teachers have an important role. My personal hope is that also in the schools there will be teachers who are willing to take these courses just for the experience, just to know, okay, these are the ways that we can teach without teachers. I know what is going on there. I know how the methodology behind it works. Maybe I can take something from there and do it in my subject. So it's a long-term cooperation, not just a one-year pilot, and we hope to build on that. So we know that we have 10 schools. We know that all the gymnasium students can start in September when it's coming up. So we are interested also in the data that comes back, and then we need to analyze it.
Of course, but I just wanted to come back to actually what you said, Maive, about teachers being the key instrument here. That I think the fundamental difference when it comes to coding school Koort is that there are no teachers. That it's a teacherless classroom and it's peer-to-peer learning. Do you see that today's high school students are actually ready for an experience like that? That are they able to actually learn on their own without having a supervisor present, without having a teacher in the classroom? Do you think this is something that can actually work?
It can work if we talk about selective courses and, this motivation, what do I need for the future? But it is definitely difficult if you talk about those subjects which you have to learn. And maybe even you don't, you as a student, you see that I don't need it in the future. And it is the point where a teacher is also important, because teacher is the one who can motivate there. So if we talk about high school, where you already learn specific skills or specific area, then it's not the same for high school or basic school, or not even for those elective courses, because those are motivational. They have motivation somehow or interest in those topics to choose that. But maybe the question is how we can raise those children from the basic school who come and already have those interests. That's maybe the key question. So I'm not sure how many are there schools, for example, in Tallinn, who actually teach, basic coding in basic school. I'm not sure, but that's the point where we should start maybe, so that they would have this interest also in gymnasium.
Do you think that this is something that could raise the advantages, the advantages of your school, in the sense that the competitive edge of your students when they graduate from your school, if they have been through classes like this where they actually learn the basics of coding and programming, then do you think this gives them a competitive advantage of some sort over some other schools or some other regions? Because as we know, education is the great, what is the term here? Equalizer. Education is the great equalizer. So do you have hopes of this kind for this project as well, that this will perhaps help to equalize the differences between the different schools, not just located in the city center of Tallinn, but also in the periphery of Tallinn?
Yeah, I think it will, or gives advantage to, not advantage, but equalizes those students of different schools.
I think another point that we wanted to take in consideration was this positive discrimination. So we know that we have schools that have their own profile, and we know that we are having the biggest reform in Estonia education of the last 30 years, which is switching to the curriculums into Estonian language, and this reflects 20,000 students currently in Tallinn. So we want those schools also to find a new profile maybe that extends the options for the students there, and also find new approaches that will stand, that it's not just there are schools that want to have one clear profile, and there are more and more the students want to have a brighter selection of different things that they can change up, changing with different paths after the 9th grade, also in gymnasium, going maybe one step back, taking 1 year off, preparing something. So it needs to be more dynamic, the learning and the options also. So we also see that probably some of the schools that start with this will have a longer cooperation, and we already know that also some schools that they have cooperations with universities already, Taltech or also universities abroad that have been growing out of these cooperations that started maybe with some selective course.
Mm-hmm. Well, excellent. On that positive note and reflection, I think we can conclude this part of the conversation. And thank you very much for coming to the studio today. And I wish you nothing but the greatest of success with your endeavors and your projects. Thank you very much.
Thank you.
Thank you.
Hello and welcome to the studio to Grete Arro, one of the leading Estonian education psychologists and someone who knows more about learning than we could ever learn ourselves. So hello, welcome to the studio, Grete, and perhaps a few words about yourself before we get started.
Hello, and thank you for having me. As you said, I'm an educational psychologist. I work in Tallinn University as a researcher in School of Educational Sciences. And as I said, my background is actually psychology, not education. And I have worked for several years in different kind of educational research projects, just to say it really, really generally. And as you said, actually, I don't think I know that much, or I know, if you work in science, you know that you don't know so many things. There is so much to discover in education, in learning, and this is really rapidly developing field of science at the moment. And I feel that it's really hard to keep yourself up to date, your knowledge. But yes, our main goal, besides the educational research, is also changing, according to the knowledge we have, the teacher education as well. Yeah.
Well, that's the reason why we actually invited you here. That since Koort Coding School is pretty unique when it comes to a teaching experience and learning experience. So there are no classrooms per se. There are no teachers. It's peer-to-peer learning and so on. Mm-hmm. So I think the fundamental question here is, how do we actually learn to learn? Mm-hmm. I think you, of all people, probably know the answer to that one.
Actually, I would like to say that I have tried to start as a student after learning all that about educational psychology. I'm a biology student on hold at the moment. So actually, if you know quite a lot about learning process, it's unbelievably easy to be a student. It's unbelievable. It's actually superpower. But what every listener should know is that if we learn without this systematic evidence-based knowledge about learning, we learn in a totally wrong way. The intuition about learning gives you all the wrong answers. So almost every intuitive understanding or knowledge about learning is wrong, and this is what we should know. If you do it, I like your phrase.
Okay.
And the main question actually is, maybe I know this podcast is not a semester long. We need a semester for that topic. But the main idea would be what everyone could use is learning is constructive process. What it means. It doesn't mean anything if you just listen to that. But the point is that learning happens only if you construct your knowledge. If you listen, if you watch others doing, if you watch others talking about whatever, then this is a passive process for your brain. You don't construct the knowledge. In a way, when somebody lectures you, it takes away the learning, the possibility to learn for that day. You have illusion of understanding. You gain this, okay, this is so easy, okay, I understand it, if you do. And this constructive phase is actually absent. And this is a problem. So actually learning is thinking. And when we listen to someone, then we actually don't think, because we only follow the thread of the talk. Mm-hmm. We just follow that, okay, I understand, and so on. I just follow that I don't fell off the car. Mm-hmm. I'm with you. But what I cannot do, I cannot connect this new information with what I already know. For example, I don't have time to give new meaning to this information. I don't have time to interpret it. I don't have time to ask questions, and so on. So to be really brief here, I would suggest a keyword, productive failure design. It's one scientist, or actually today many scientists who put this idea of constructive learning and actually many other things about it in a really practical way of teaching and learning. And one main idea behind it is that our brain is really ready for learning when the brain makes a mistake itself. Okay. It's not hearing from others how things go wrong. It's not listening to other people's mistakes. It's designing a task for students where students fail. Definitely, they have to fail. It shouldn't. It's not problem-based learning. Mm-hmm. In problem-based learning, students usually doesn't fail. It's designed to be successful. And studies say that if failure is there, if this impasse is there, learning is more effective. What it does with your brain, we all know that. We all have done mistakes, and we feel quite bad when it happens. And actually we should rewire that in our brain in a way that if we understand, actually in our lives, when small children learn how to walk, they are not discouraged from falling down.
Mm-hmm.
They keep on. They somehow know that actually it's a part of learning. And in our education system, we fucked it up, sorry, but we do it. And today we are so afraid about failures because we feel that it measures us.
Mm-hmm.
It says that we are not capable of something. But in this productive failure design, you all Google already about, you find Manu Kapoor and TED Talks and many scientific articles. The idea is really to give practice before theory. Because theory has to land somewhere. We don't understand theory. Theory is an answer, how something works. And if you don't have the question, the answer doesn't glue in your brain. It doesn't have, you didn't have question in your own mind. And if you design a task, okay, you have to find out how something works, how to do something, how something is built up, whatever. It's those are not trivial questions. Those are not easy questions. They should be solved collectively. Maybe 3, 4, 5 group students in this group. They should have time to discuss, to collect all what they know. In this process, they activate the pre-knowledge what they have, because this is really healthy for learning. And they definitely fail, meaning that they end up somewhere where they have maybe some not really optimal solution, or no solution, or many solutions which are not optimal, and they understand what they don't understand, and they understand how it doesn't work, how not to do it. And this is really important part. And this is the part where theory should follow, but of course not in a pure lecture form, but maybe in a form of discussing all solutions of the groups and discussing why they don't work, what works and why, and so on. And so it's kind of like lecture / discussion or yeah. So experts have a role when students have questions in their own, and then is the lecture useful. So it's delayed instruction is it called. We separate direct instruction, which is normal school, and in Koort you don't have that, and you are really fortunate. And then we talk about delayed instruction and productive failure, that meaning practice first, theory later. And this practice, I know many people think when I say that okay, but how we teach doctors in that way? But of course, learning never means that you do real things. You never manipulate real people, real money, real whatever, real children. So we always practice in artificial. The problems are real. The problems are hard, but the situation is not real. And yeah, so this is something we all could use, and we could all start to acknowledge that when you don't fail every day, then we're not learning. And what happens after failure is actually start of the learning process. Yeah. But
you also, when you talk about failure, then as you grow older, then your approach to failure also changes. I mean, when you're younger, you're more risk prone, you're open to challenges and things like that. As you grow older, you become more conservative, and your risk-taking abilities are slightly less than they used to be. So the same thing happens to learning as well, that it changes when you're compared to when you're 19, compared to when you're 29 and when you're 49, as is represented in the age groups that are make up the students of Koort Jõhvi. So in that sense, do you have some special points or notes that you could share with people of different age groups, how they should actually rewire their brains or change their approach to learning based on their age actually?
Yeah, this is really good perspective you put in there. I mean, when you have really what we call growth mindset. So understanding what is learning. So learning is possible for the brain, for all brains. It's always possible. It's always possible to learn, but only through mistakes, only through effort. And when we grow older, then yes, maybe many older people really have kind of understanding that if you are not perfect all the time and from the day one, then it's not in you. You don't have capability to do it at all. So this is, we call it fixed mindset. It's one of the most influential motivational theories from Kaarel Rundu. We all know that probably. And this can be one difference between people. So people can, when they are the older they are, they might be more. They tie their failures with their self-worth, and they think that when they fail, in this age you shouldn't fail anymore. In this age, you should already know how things go. You should know how to learn, and this is it's really bad thing actually. So what I think that in Kood, it would be really useful if students would know or learn some of the principles of learning. For example, that one. For example, the idea that many of us have inside the implicit belief that we don't phrase to anyone, that maybe when I fail, then maybe it means that I'm failure. Maybe it means that my brain isn't capable for learning, but it's wrong. It's wrong with brains that really have some problem. I mean, neurologically, the brain is meant for changing. This is the function of the brain. But what disturbs the learning the most is this fear, is this implicit belief that, okay, when I fail, everybody stares at me weirdly and so on. It means that I shouldn't try anymore. But there are other things as well related to age. We know that the brain is more flexible, more neuroplastic when we're younger. So it means that when you're 19, learning is way easier. But when you're older, it's still possible. It's just a little bit harder. But what is the benefit of being old? You know probably many benefits of being old,
yes.
But one of those is that your self-regulation is way better. So what's changing? When you think about people in their early 20s, their prefrontal cortex is actually not mature yet. They are not fully developed in regarding self-regulation, executive functions, working memory, inhibition, cognitive flexibility, and so on. So those are the processes that actually lead the learning process. When those processes doesn't work well, then learning is also harder. And the older you get, it's likely that your self-regulation also is better, so you can organize yourself better in a better way. So a small decrease of neuroplasticity is compensated by this growth of self-regulation. But of course, self-regulation is something we also have to develop. So if it's not developed in young age, we also know that, maybe looking around you, older people, not all of those are able to regulate themselves. They're just old and unregulated.
Okay, but so one of the points that you're actually making here is that it is possible to develop any skill at any age. It just takes a bit more work.
Yes.
So we can forget about all these excuses that people are hiding behind, sometimes saying that I should not go into coding or programming because I know absolutely nothing about maths. I'm a life sciences person. I'm not someone who has a brain for real sciences, so to speak. And at the same time, other people who might think that this is not for me because my mind is not able to focus anymore. I have attention deficit disorder or something like that, and I should therefore not pursue any of these things that require really focused work. But you're saying that actually these are just excuses that people are hiding behind, and we can do anything. And we put our minds to.
There is maybe only one group of exceptions. If you really have some kind of diagnosis, then the path can be different. So it might demand different kind of rehab for you, different kind of ways how to help yourself to learn. But learning is still possible. But you are right. The main barrier between you and learning is this belief that you cannot do it. Because if you believe that you cannot do it, then your motivation to put in effort is really low, because it's really irrational. If you know that it's impossible, why bother? Why to do it? Why should I spend time, money, and everything to do it if my brain isn't changing? We know that in order to create new neuronal path, it takes time. It takes repetitions. So you need to do something for many times, and at the same time you have to actively inhibit if you have this kind of wrong path or some kind of knowledge or path you which doesn't help in this context. So always this older path wants to activate, and this feels from outside, it feels that I'm not able to react differently. I'm not able to understand it. What is the saddest thing in Estonia probably is this widely distributing idea of some people are math people, or some people are like humanitarian people. So it's wrong. We don't have math brains. We might have some people who are really exceptional in math, but it doesn't mean that other people cannot be. And it also doesn't mean that what we know actually is that mathematics is understandable for everyone. Maybe everyone doesn't get the Nobel Prize, but it doesn't usually. It's not what we need. But in coding, I understand coding is not only about math. It's it is kind of comfortable to believe that I cannot do something. And I totally agree that, okay, we don't have to learn all things in our lives. So because we don't have time to learn everything, because learning takes time. But if you have this secret dream to learn whatever you want to do, whether it be, skiing or coding, so it is possible.
Okay.
You might not get the top in the world, but you can master it.
So enough of hiding behind excuses. It's time to get off your seats and enroll at coding school Koort.
Exactly.
Simply as that.
And use wise learning strategies, which you'll probably discuss in some other episode.
I think we will definitely come back to that and try to have a bit more focus on our future conversations. But thank you for the very inspirational and interesting conversation we've just had here today. I do hope this will not be the last of our encounters here, but we look forward to welcome you back to the studio sometime in the future. Thank you very much, Grete.
Thank you.
Thank you for listening to Koortcast. We hope you enjoyed today's show, and please make sure to visit Koort's website for further reading and other episodes. Remember, it's koort.tech. Once again, kood.tech. Be seeing you.